Hello everyone. In this problem, this is Leetcode 198 house robber problem. I'm solving it as a daily Leetcode problem. In this is a medium range problem where we can say that the statement is stated as: you are professional robber planning to rob house along the street. Each house has certain amount of money at stake. In the only constant stopping you from robbing each of them is adjacent house have security system connected. It will automatically contact the police if two adjacent houses are broken into the same night. So we have given an array which is 1 2 3 1. So from that, what we can observe, like let us take this example. So 27931. Okay, so let us take this example 27931. So what we can see over here is that the robber can steal in two ways. That is, he can rob from the first position or the second position. If he rob from the first position, he has to jump to the second nearest element, second nearest index or element to rob, because he cannot rob the adjacent one. That will not allow in this problem. So yeah, so then we can if we store that, then we can say that we have 2 to 9, and from 9 he can jump to 1. And we have another option, which is we have another possible option, which is jump from the second position to third position, then to end. So second position to third position, then to end. So that way we will get 7 and 3. And what is the possible? This is 12 and this is 10, so the maximum is 12. So this will be the answer. Now there is a catch, as this is a medium range problem. There is a catch over here. Like, what if we have to, let's take this problem, 2 7 9 3 1, and then we have like value like 14. So now what can we do? So we have like two ways. Like, what we can say that we have two ways, like 2 9 1, then it will be like 2 9 1, and another will be like 7 3 and 14. So what is the sum of this? This will be like 12. And what is the sum of this? This will be like 24. Maybe I took a little bit of extra value. So for demonstrating the edge case, we are taking it as 10. So if that is 10, then we'll have value like 20. If this is 10, then we'll have value like 20. Okay, so for 20, we can see that by these two portion we can achieve either 12 or 20. But is this the only way to achieve this code? No, there is another approach. What if we take 2 to 9, because we cannot take 7 obviously. Then we take not 3 or not 1, we will take 10, as 10 is much bigger than 1 or 3. Then what we will have? We will have 2 to 9 to 10, which is 21. So ultimately we can see that we have a larger value, which is 21, because we don't have any. But what if we have another option, which is like 11? Then we have 9 7 3 10. Will we choose 10 or we will choose 11? Yeah, so from this observation we can see like we will have multiple options. Like, we can move to index I plus 1, or index I plus 2, or index I plus 3. We have possible two solution. We can demonstrate this as like a graph, that we have a starting point. From there we can take from this point we can take like two possible option. one is like the first index, another is like the second index, second index. And from 2 we can take two steps, like we can take either 9 or we can take either 3. Yes, we both are valid, but why, you can have a question like why we are not taking 2 to 1, but this is not needed because if we choose 1 we can also choose 9. So yeah, ultimately two possible options is more than enough. From 9 we have two options, either we can take 1 or take 10. So from 1 and 10. Also for 3 we have two options, either take 10 or take 11. Take 10 or take 11. Also same as we will have another options, like from 7 we can iterate to 3 or to 1. Now from 3 we have already demonstrated that from 3 we can iterate to 10 or 11. Listen, from 3 we are redundant the iteration, and from 1 we have only one option because the another index is empty string. So we can take from 1 we can take 11, or else we have no options. So now here this is the going through we will iterate, but what is the catch here? We can store this part of portion, we can memorize this part of portion in a bigger sense. If we think in a bigger sense, we can memorize this part of portion. So ultimately when we are storing, like if we store it is as a memorization, so if we store as a memorization of index is what? Index is 0 1 2 3. For 3 we the index is also 3. If we index 3 and we know what is the largest value here, the largest value is 11, so we don't need to iterate again, like which is the answer. So from that we can get the our desired value, and from then again we iterate back, we add the m of 1 equals to like 11 plus 3 plus 7, which will be like 21, and then we return back the value. Yeah, so what we need to actually test is like the maximum value that is stored in this position and the maximum value that will be stored in this position. So from this we can easily solve the question. So now look at the solution that we have made over here. That is, we have a we are taking a memorization or DP for that, and inside the method or inside the function we are setting or we are setting all the DP value to -1 for the initial value, and if the size is if our vector size is 1, then we will returning the first value obviously, or else we will comparing the maximum value of the first index and the second index. So for the first index we are indicating 0 for as the first index is pointing as 0, and the second index is pointing as 1, and also we are sending the largest value in the function and also the vector. In the function we are checking if the index is greater than the last index, because we are iterating like 2 and 3. So we can have some cases that which will be pointing out of the array. So out of the array, then we will returning the 0 if we got the last index or the second last index, which is if we got this index or this index, we have to return this value because this index will be storing in the previous step. So here we are returning this value. If we already have a memorized value, then we'll returning the memorized value. We will not calling the method again. So we are returning this we are returning the DP. If DP is not -1, that means DP has already been iterated, So dp has already a value, so we are returning that value, and in the end we are storing the dp of I. We are storing in these indexes, in this index, in this index, in every index we are storing this current value plus the iterated value. What is the iterated value? We are iterating the I plus 2 and I plus 3. So we are iterating either this or either this, and from this portion we are what we are catching, we are catching the largest value, which is 10, and from this we are catching the largest value, which is 11, and from both of these we can assure that we are assigning this value with that. Yeah, and then we are returning this. I have already run the code, and we got the 100% of success in this code. So I hope you have get a brief idea of how this kind of problems we have solved. So yeah, thank you everyone.